Exponents, so we're going to start to talk about zero and negative exponents. But before we begin, let's do a little review of exponents. And I want to compare these two as a reminder. These are the ones that people miss the most. This is telling you to write the -4 2 times. This does not have parentheses. The parentheses really are only around the 4. So we have -4 times 4. This gives us 16. And this gives us -16. So you can see the difference between the negatives being included in the parentheses and the other ones not. Okay, what we want to talk about next is what happens when we have negative exponents. So from this pattern, we're going to determine what a zero means. So what does zero mean when it's an exponent? We're also going to determine what it means to be a negative exponent. So because what we know from powers, we know that this says 3 times 3 times 3, which would be 27. We know that this says 3 times 3, which happens to be 9. We know this just says 3, which is 3. So we need to figure out what is 3 to the 0 power. Well, look at the pattern here. Really what we're doing is we're dividing by 3 every time. So 27 divided by 3 is 9. 9 divided by 3 is 3. And so if I take this and I divide by 3 again, 3 divided by 3 is 1. So that means 3 to the 0 power is 1. Then if you continue this pattern, you divide by 3 again, you end up getting 1 divided by 3, which is a fraction of 1/3. So really what negatives do is they don't make the number negative, they put the number on the bottom of a fraction. So we'll do it again. 1/3 divided by 3 is like saying 1/3 times the reciprocal 1/3. So that would be 1/9. Well, that is really 1/, like I said, this says move it to the bottom of the fraction, 1/3 squared. And this last one then would be 1/3 cubed, or 1/27. So let's look at this pattern again with some different numbers. This time let's do it with 2. So we have 2 times 2 times 2, which is 8. We have 2 times 2, which is 4. And we have 2, which just is 2. So as you're looking for the pattern, you notice that it's being divided by 2 every time. So 2 divided by 2 is 1. So therefore, again, anything to the 0 power is going to be equal to 1. So we take 1 divided by 2, that's 1/2. So a negative exponent just moves the number to the bottom. Using that method, this just means that this is moved to the bottom, so it's 2 squared, which would be 1/4. 1/2 divided by 2 is 1/4. And then this would be 1/3, or 1/2 to the 3rd. That would be 1/8. So what is the pattern here? Well, this is just x cubed, x squared, x. We now know that this is equal to 1. Notice each of these are being divided by x, and then divided by x. X divided by x is 1. 1 divided by x is 1/x. So then if we divide by x again, we get 1/x squared, and then 1/x cubed. So this is the reasoning behind negative exponents and 0 exponents. Alright, looking at this, we have found the pattern. We know that anything to the 0 power is 1, and we know that negative exponents create fractions. They don't make the number negative, they create fractions. So we're going to write those things down. Make sure you've written these down. Any value raised to the 0 power is equal to 1. So I'll just give you a couple more examples of that. I could say 4 to the 0 power, that's 1. I could say 2.76 to the 0 power is 1. So anything to the 0 power is always going to be 1. The other thing we just looked at is negative exponents and what happens. Well, negative exponents, we looked at them in this manner, where if it's on the top of the fraction and we want to make it a positive exponent, we move it to the bottom of the fraction. The other thing I want you guys to know is that if it's on the bottom, so if the negative exponent is on the bottom of the fraction, what you're going to do is you're going to move it to the top and it will become positive. I always like to say whether or not they're happy. So this guy isn't happy, so he moves to the bottom of the fraction. And this guy isn't happy being on the bottom of the fraction, so he moves to the top of the fraction. To simplify negative exponents is just what I just got through saying, but this is just in words. Move the power with its base to the other side, top or bottom of the fraction, and make the exponent positive. And then you simplify. So negative exponents is another thing I've already stated out loud. Negative exponents do not affect whether the expression is positive or negative. Very, very important. They do not affect whether or not it's positive or negative. So all we're going to do is we're going to go through quite a few examples, and we're going to get rid of the negative exponent. So anytime we're asked to simplify with a negative exponent, our answer should never have a negative exponent in it. So what I'm going to talk about is being happy. So this guy is not happy right now. He's on the top of the fraction. I know he's on the top of the fraction because this is like over 1. So I'm going to move him to the bottom of the fraction. He's now happy. And then I'll simplify this. So this says 1 over 4 times 4 times 4. 4 times 4 times 4 is 64. So my answer is 1 over 64. The second one. This guy is not happy. So I move him to the bottom of the fraction. And I now simplify 3 times 3 times 3 times 3. That is 81. So I have 1 over 81 as my answer. The next problem. This guy is on the bottom of the fraction, but he's not happy there, so he's going to move to the top of the fraction. So it'd be like 7 over 2 to the first power, but we don't need to write this part. And so we just say 7 to the second power. 7 to the second power is 49. The next one, we know anything to the 0 power is 1, so we just write 1. Now let's look at a few more that are hard. Before we do that, let's go ahead and write this down. An algebraic expression is in simplest form, and this is what I just said. I don't want to see any negative exponents written in your final answer. So you know an expression is simplified when it has all positive exponents left in it. So we get ready to go on here. This is what algebraic expression I have. Notice the parentheses are here. So this says everything, this whole thing is to the 0 power. We know anything to the 0 power is 1. So it is really that simple. And then this next problem, I've got certain things that are not happy. And what I'm going to do is going to highlight anything that's not happy. Anything that's not happy, we need to move. So the 4 and the y stay where they are. This one's not happy, so it moves to the bottom and becomes happy. The next problem, I have just this one that's not happy. I want to highlight the things that you know you've got to move. So you're going to keep the 3a, it's happy, and you're going to move the b squared. And you're finished. The next problem, I'm going to highlight what's not happy, which happens to be the w to the negative 4th. So it wants to move to the top of the fraction, and it's finished. The next one, we've got the x to the negative 3rd that's not happy. Everything else is fine. So we keep the 2 and we move this to the top of the fraction and it becomes happy. Alright, one more time. To evaluate an exponential expression, we're going to make all the powers positive. We're going to substitute those values in and then we're going to simplify. Be careful for your negatives. A negative exponent doesn't make a negative number. You need to keep that in mind. So again, I'm going to do this the same way I was. I'm going to first highlight what's not happy. I'm going to keep the things that are happy where they are, but I'm going to move the unhappy part and it goes to the bottom. The next step I want to do is evaluate these. So I've got 3 on the top. I have an x, which is a 2 squared, and on the bottom I have a negative 3, and notice how I'm putting in parentheses squared because it is the y. The whole y is being squared. So I end up with 9 on the bottom because that's negative 3 times negative 3. And here on the top I have a 3 times 2 times 2. That would be 12. Now we could reduce this because 3 goes into both of those to be 4/3. The next problem, we're going to highlight anything that's not happy. We're going to leave everything else that is fine or happy alone, and we're going to move that to the bottom, and then we're going to simplify. Well, we're going to plug in negative 3 for the y, and we're going to plug in 2 for the x. Notice that gives me 1 on top. Anything to the 0 power is 1, and you could have done that way back here if you wanted to. And then the bottom we have 2 times 2 times 2, because that's what 2 to the third is, which is 1/8. On the next problem here, I have the x to the negative 1 that is unhappy. We're going to keep everything else that is happy where it is, so the y to the second's on the bottom. The x to the first gets moved to the bottom, and I just end up with a 1 on top because I can't put a 0 up there. We're going to then say I have 1 over, this would be 2 to the first power, and I'd have negative 3 to the second power. So what I end up having is I have 2 times, and this is a negative 3 times a negative 3. Well, that ends up giving me negative 6 times negative 3 is 18, 1 over 18.